Introduction. Matrix Algebra. Matrix is a rectangular array of numbers called elements arranged in rows and columns. A matrix with rows and columns is called a matrix of order m times n. Aij indicates the element in the ith row and j the column. Inverse matrices. If A and B are m times n matrices, then the matrix B is the inverse of matrix A, or B is the inverse of A. If and only if AB equal to BA equal to I. Methods to find inverse matrices: elementary row operation and adjoint methods.
Okay, I'll present the elementary row operation, also known as ERO. What is ERO? ERO is a process that can be used to find the inverse of matrix by interchanging, multiplying, or adding the item and j the rows until we change the matrix A into the identity matrix I. There are few things that can be used in ERO. One of that is interchange the item row with the j-term row of matrix. Second, multiply the item row of the matrix with a scalar k or the constant k when k cannot be equal to 0. And the third one is adding the item row that is multiplied by a scalar k, constant k, to the j-term row where k also cannot be equal to 0. There are a few steps that can be derived to simplify our calculation in using the ERO. Firstly, write matrix A with identity matrix I next to it, and we call it augmented matrix form in the form of AI. Second, perform ERO until we get new augmented matrix IB by using of combination, addition, multiplying, and swapping. And at the end of our calculation, we can get inverse of A will be equal to B, which is the form of matrix A will be changed to the identity matrix I. Therefore, the identity matrix I will be B, and it is the inverse matrix that we're gonna get.
Now moving on to the example 1, which using the elementary row operation to find the inverse matrix, which also known as ERO. Here is the example question with matrix A, and we need to find the inverse matrix of matrix A. Okay, now we'll try to find the inverse matrix of matrix A by performing the elementary row operation ERO. At the very first step, we need to write down the matrix A, and next to it, we need to write down the identity matrix, which called as augmented matrix. Next, we need to try to convert the matrix A at the left part into an identity matrix. So we will be more focused on the left side. First of all, I would like to change the first number in row 2 and row 3 to become 0. In order to get the 0, I would like the row 2 to plus with row number 1 that will multiply with 2 over 3, and I would like the row 3 to minus row 1 that will multiply with 5 over 3. And the whole working step will be like this. Okay, now I will get the first number in row 2 and row 3 to become 0. Next, I will change the second number in row 1 and also row 3 to become 0 as well. So I will let the row 1 to plus with row 2 that will multiply with 3, and I also let the row 3 to plus with row 2. So this will be the whole working step, and we'll get the second number to be 0 at the row 1 and also row 3. Moving on, I'll multiply 3 to the second row in order to get the second number in second row to become 1. So the second row will be 0, 1, 0, and the third row already 0, 0, 1. So now we left the first row to become 1, 0, 0 in order to get a complete identity matrix. So now I would like to let the row number 1 to minus with row 3 that will multiply with 6, and the whole working step will be like this, and we finally get the first row to be -3, 0, and 0. Okay, now for the very last step, I'll multiply negative 1 over 3 to the first row in order to get the first number in the first row to become 1. And now, we already get the identity matrix for the left side, which is 1, 0, 0, 0, 1, 0, and also 0, 0, 1. And the matrix next to it will be our inverse matrix or matrix A.
Now, we will discuss another example of how to find inverse matrix by using ERO. Calculate the inverse of matrix B with element 1, negative 2, 3, 3, 5, 1, 6, 4, 2. So, first step is to form the augmented matrix BI. So, we copy the matrix B to the left-hand side and the identity at the right-hand side. Second step is to perform ERO until we get the new augmented matrix using addition, multiplying, or interchange row. In this case, since our first number in row 1 is 1, our target is to make the first number in row 2 and 3 element to become 0. Therefore, we need to take the element in row 2 minus with 3 times row 1 element, and row 3 minus 6 times row 1 element, and this is our first working step. And as stated here, the first row elements in the new matrix will remain the same. After that, to make the second number in row 2 to become 1, we need to times the elements in row 2 with 1 over 11. And we will obtain this without changing the elements in row 1 and 3. Since we have obtained 1 in the second row, we need to make the second number in row 1 and row 3 to become 0. By taking the row 1 elements, 2 plus with 2 times row 2 and row 3 elements minus with 16 times row 2, this will be our working step, and we will get 0 in both row 1 and 3. In order to make the left-hand side to become an identity matrix, we need to make sure the third number in row 3 is equals to 1. Thus, we need to times row 3 elements with negative 11 over 48, and we will make the third number in row 1 and row 2 to become 0 by taking the row 1 element minus with negative 17 over 11 times row 3 and row 2 elements plus with 8 over 11 times row 3, and we will obtain this as our working step. A gentle reminder, please be careful while multiplying the elements with fraction because the working step can be quite lengthy. And lastly, this is our new matrix, and you notice that the left-hand side matrix is now an identity matrix, so that means matrix at the right-hand side is the inverse matrix. We get B inverse equals to negative 1 over 8, negative 1 over 3, 17 over 48, 0, 1 over 3, negative 1 over 6, 3 over 8, 1 over 3, and negative 11 over 48. So that's how we find inverse matrix by using ERO.
Adjoint method. The adjoint of a square matrix A is the transpose of cofactor matrix, which can be obtained by interchanging every Aij element with the cofactor Cij and denoted as adjoint matrix A equal to the transpose matrix of Cij. If determinant matrix A doesn't equal to 0, the inverse matrix A then exists. Therefore, the inverse matrix A equal to 1 over determinant A times adjoint matrix A.
Now, let's move on to the first example, find the inverse matrix using adjoint method. The example given shows matrix A contains the element 1, 3, 2, 0, 2, 2, negative 2, negative 1, and 0. First step is we need to find the determinant of matrix A. To find the determinant, we can choose any row or column and multiply each element by its cofactor. Here, we will choose the first row. The mathematical equation for determinant will be like this. Element 1 times with its cofactor minus element 3 times its cofactor plus 2 times its cofactor. By the end of calculation, the determinant will be -2. Next, the second step is replacing each element by its cofactor, and we will get the cofactor of matrix A is 2, -4, 4, -2, 4, -5, 2, -2, and 2. After finding the cofactor of matrix A, we need to transpose it by interchanging the corresponding rows and columns. We will get the answer adjoint A as shown here. The final step is finding the inverse matrix. We can calculate the inverse matrix A by multiplying 1 over determinant that we calculated earlier with adjoint A. And the final answer for inverse matrix A will be -1, 1, -1, 2, -2, 1, -2, 5 over 2, and -1.
This is another example of finding inverse using adjoint method. For adjoint method, the first step you have to do is to find the determinant of the matrix. So the first step we have to do is we can choose any row or column of a matrix to find the determinant. So in this case, we will choose the second row because it's quite easier compared to other rows or column. So after expanding the second row, we will get the determinant is -2. After finding the determinant of the matrix, the next step you have to do is to calculate the cofactor matrix. So we will start with first row. For the cofactor of 2, after calculating, we will get 8. For cofactor of 1, and it corresponds to the negative right here, and we will get -4. So for cofactor of -1, and we will get 14. After finding the cofactor of the first row, we will do the same thing in second row. So for the cofactor of 2, after we expand it, and we will get a -7. So for the cofactor of 4, we will get 3, and here will be positive. So for cofactor of 0, we will get -11. So the same thing will go to the third row. By using the same method, we can get the cofactor for the third row. So for -1, we will get 4. And then for cofactor of 5, we will get -2, and the last one for cofactor of 2, we will get 6. So after finding all the cofactor of matrix, in step 3, we have to transpose the cofactor matrix. So what is meant by transpose? Transpose is actually a process of switching rows into columns in the matrix. So after finding the transpose, we will get adjoint B. For the final step, all we have to do is just to divide the adjoint B by the determinant to find the inverse matrix. So in this case, we just need to divide the adjoint B by -2, and we will get the inverse matrix of B.
Alright, we already finished on discussing on how to find inverse matrix using elementary row operation, ERO, and adjoint method. Before we end this video, I would like to summarize on what we learned in this topic to make you more clear and for your better understanding in this topic. Firstly, we need to know in finding inverse matrix using ERO, we need to do a simple operation by adding, multiplying, and also swapping between the row of matrix. So you need to recall back on your previous topic ERO and make sure you already expert using ERO method. Back to our inverse matrix. As you can see below, when you finding inverse matrix using ERO, you need to write down your matrix in the form like an example below, where matrix A along with the identity matrix next to it. Remember, to find inverse matrix, you need to change matrix A become identity matrix using ERO. By applying ERO to find matrix, your result will become like formula below, where inverse matrix will become identity matrix, or known as RREM, and identity matrix will become the inverse matrix. For adjoint method, firstly, you need to know the inverse matrix is exist or not by finding its determinant. Remember here, after you get the value of determinant, and if the determinant value is 0, it means that the inverse matrix does not exist, so you cannot proceed your calculation to the next step. However, if the determinant is not equal to 0, it means inverse matrix exists and A is non-singular matrix, so you can proceed your calculation to the next step. To find inverse matrix using adjoint method, you need to follow this formula, where inverse matrix equal to 1 over determinant A times adjoint matrix A. Here is the important part in adjoint method you need to remember. The adjoint method requires 3 steps. The first step is find the determinant. To find the determinant, choose any row or column and multiply each element by its cofactor. The determinant is the sum of this. Second, calculate the cofactor matrix. Third, transpose the matrix of cofactor and divide by the determinant.